Welcome to NGIT Math Podcast today. My name is Tao Ling, and I will try to explain to you how to simplify a square root. Okay, so first of all, you need to know certain identities of a square root. So those are, you can have square root of A multiplied by square root of B, and then it's going to equal to square root of A multiplied by B. And also, you can have square root of A divided by square root of B, and that could equal to square root of A divided by B. Okay. However, you cannot have, so this is you cannot have square root of A plus square root of B. It's gonna equal to A plus B. This is utterly wrong. You can't have that. And also square root of A minus square root of B is equal to square root of A minus B. No, that's wrong. You can't have that. Alright, so after we get that out of the way, let me just cross it a couple more times. Now you can actually go into some real examples. Let's say square root of 117. So we would like to simplify this. Well, 117 is not really a perfect square. I mean, what's a perfect square? Well, 25 is a perfect square because 25 is equal to 5 square, right? And 36 is a perfect square. It's equal to 6 square. It's very perfect. But 37 is not a perfect square because there's nothing that there is not a whole number that after you take in the square, it'll give you 37. So since 117 is not a perfect square, you can the result is not going to be a simple number. It's not going to be a whole number. But however, we could try to factor 117 into two parts. One part is a perfect square and the other part isn't. Okay. So first of all, we know that 117 can be factored into 3, right? 3 multiplied by 39. Okay, so is 3 or 39 a perfect square? Not really. So let's keep going. So we can also factor 39 into 3 and 13, right? So, okay, now we have 3. We actually have this part, 3 multiplied by 3. So we can actually write it as square root of 3 squared multiplied by square root of 13, right? Using this identity here. So it becomes 3 squared multiplied by 13. 3 squared is 9, and that's actually a perfect square. And from there, we can actually get rid of the square root sign and just write 3. This part becomes 3. Square root of 3 squared is 3 multiplied by 13. And then that's how we simplify 117 into 3 multiplied by square root of 13. The way to do this is that you always try to factor the number inside the square root into two numbers. One that is perfect square and the other isn't. So one part is perfect square and the other isn't. And then you can simplify it into a form where it's a number multiplied by a square root. Okay. So now let's try another problem. Square root of 6 multiplied by square root of 12. Well, square root of 6 multiplied by square root of 12. First of all, neither 6 nor 12 is a perfect square. Okay, so let's factor it out first. 6 can be factored out into 2 times 3, right? And 12 can be factored out into 2 times 2, which is 4 times 3. So 2 times 2 times 3 is 12, okay? Now, we can pair them up. We can pair 3 with 3 and 2 with 2, and this would give us 2 times 3 squared times 2 squared, right? And if we use the identity we just learned, this can be written as square root of 2 multiplied by square root of 3 squared multiplied by square root of 2 squared. And guess what? This is going to become 3. This is going to become 2. So the answer will be 3 times 2 times square root of 2, which is going to be 6 times square root of 2. Okay? So you see what I did? So the first step is you try to factor the numbers into its lowest factors, and then you try to group two factors that are the same. So group 2 with 2 and 3 with 3, and then you write it into a square form. And then if you do that, those numbers can actually be the square actually can cancel out with the square root, and you become a real number, and you free yourself from the square root and then come out as a real number being. Well, anyway, so that's how you do it. So it's as a 6 square root of 2. Let's try another problem with letters, okay? With letters. So letters, no letter. 48x square, right? So maybe we should break it into two parts, one number and one letter parts, okay? Well, now we can consider it as two problems. One problem is this 48, and the other problem is square root of x squared. So one thing you do have to know, well, the number part might be easier, because 48 we can break it up into 2 times 2 times 2 times 2, that's 16, times 2, times 3, right? So there's 4 2 and 1 3, right? That's 48. Because 2 times 2 is 4, 4 times 4 is 16, 16 times 3 is 48. And then multiply by square root of x squared. Now 16 is, well, this part it's really square root of 4 square, right? Because 4 square is 16, and 2 times 2 times 2 times 4 is also 16. 4 square times square root of 3 times square root of x squared, okay? Now this is going to be 4 times square root of 3. Now that is going to be x, but here's the tricky part. Remember our definition said earlier, the square root can only be a positive number, but however we don't know if x is positive or negative. But the result has to be a positive number. So how do we do this? Well, there's one way to guarantee x to be a positive number, that is putting an absolute value on x, okay? So absolute value here guarantees that the square root of x squared is going to give you a positive number. So that's why we have to place an absolute value around that. Okay? So here you go. That's the final solution. So if you see a part with both numbers and letters, you can factor out you can do the numbers and letters separately. The numbers you just factor out as in the ways I taught you and I told earlier, and the letters, square root of x squared, you just have to pay attention to make sure that the result is always going to give you a positive number, and then you usually guarantee that by giving it absolute value. Okay? Well, so that's it for now, and thank you for watching. Enjoy your study.